Alright, in this video we're going to look at just one single example of solving a trigonometric equation, and this particular trigonometric equation is what we call one that's in quadratic form. Right, so the equation we're trying to solve here is 2 cosine squared of theta minus 7 cosine theta plus 3 equals 0. Right, so when I said it's in the quadratic form, if you're looking at this you might be able to understand what I'm saying. A quadratic equation would be like 2x squared minus 7x plus 3 equals 0. That would be a quadratic equation. All right, this one is not quite that, because we don't have x's there, we have cosines, but we have a cosine squared term, and then a cosine term, and then a constant term equal to 0. So it has that quadratic form, where it's something squared, and then that's something to the first power, and then a constant. So what I can do to approach this is I can try to solve this equation as if it were a quadratic equation. Right, and it may help to do a substitution of variables here. So let me say that x is equal to cosine of theta. All right, so I'm going to make a substitution of variables here. Instead of cosine theta, I'm just going to replace that with x. So where I have 2 cosine squared of theta, that's going to be 2x squared. Right, because cosine squared of theta, that's this thing squared, so that's x squared. All right, the minus 7 cosine theta, that's going to be minus 7x. And then plus 3 equals 0. All right, so if I make that substitution of variables here, what I end up with is a quadratic equation. Right? 2x squared plus 7x minus 7x plus 3 equals 0. I said that backwards. All right, so now we can solve this like we solve quadratic equations. So I can try to factor it. I can try to use the quadratic formula. And you might be sitting there thinking, well, I'm trying to solve trig equations. Why am I now worried about solving quadratics and factoring in the quadratic formula? I already did all that stuff. I left it behind. Why is it coming back again? Well, the thing about mathematics is, anything that you learn along the way might come into play in any given problem that you see. Right? In this case, we're solving a trigonometric equation. And guess what? It turns into a quadratic equation. We need to use our methods for solving quadratic equations in order to solve this one. Right? So it's one of the things that I like about math is that anything that you ever learned could be relevant to the next problem you sit down and try to do. Right? So you have to remember all those skills that you had previously. How to factor. You have to remember what the quadratic formula is. If you can't factor this one, you're going to have to use a quadratic formula. Right, so it makes you not, or doesn't let you forget anything that you learned along the way. So you just have to be aware. Pay attention to the structure of the equation. If you have something squared and then that's something to the first power and then a constant, it doesn't matter what this is. It could be a trig equation or a trig function. It could be an exponential or a logarithmic function that's being squared and then being to the first power. If it's in that quadratic form, you can replace the cosine theta in this case with an x, and then you solve it like it's a quadratic equation. Right? So let's see if we can factor this quadratic equation, and if we can, we will. If not, we'll use the quadratic formula. And if you don't want to try to factor it, if you'd rather just go ahead and put it into the quadratic formula, you can go ahead and start working on that while I try to factor it, and at the end we should come out to the same solutions. Alright, so if I'm going to factor this, since there's that number in front of the x squared, this goes to the AC method of factoring a trinomial, which I did a video about the AC method a while back, so if you're not sure what I'm talking about, you might want to go back and review that video of how to factor something that's in this form here. But basically what we do is I multiply the 2 times the 3, which is going to give me a 6. So I'm going to look for 2 numbers that multiply to equal 6 and add up to equal that negative 7 that's in the middle. All right, so I want 2 numbers that multiply to 6 and add up to negative 7. Well, that's not too hard to find. Right? So if I do negative 6 times negative 1, that's going to multiply together to equal positive 6. But if I add those numbers together, they're going to add up and equal negative 7. Right, so those are the numbers that I'm going to use here, negative 6 and negative 1. All right, so I find those 2 numbers, and then what I do with those 2 numbers, I split apart this negative 7x. All right, so it's 2x squared minus 6x minus 1x plus 3 equals 0. All right, so the 2 numbers that I found that multiply to, again, they call this the AC method because it's, the 2 is my a, right? It's ax squared plus bx plus c. So 2 is my a, 3 is my c. I multiply those, a times c, to get my 6. That's the number I have to multiply to, and I have to add up to that one that's in the middle, the b. And then I use the numbers I find to split apart the b to create 4 terms, and then when I create those 4 terms, I do factoring by grouping. All right, so I take the first two terms, the 2x squared minus 6x. What do those two have in common? Well, they have a common factor of 2x. And if I factor out the 2x, I'm going to be left with an x minus 3. All right, the minus 1x plus 3. They don't really have anything in common, but I have to pull something out. And when I pull that something out, what's left in the parentheses has to be the same as this one, x minus 3. Well, I have the 1x and I have the 3, but the signs are different. So if I pull out the negative 1, that'll leave me with a positive x and a minus 3 equal to 0. All right, so that's our factor by grouping there, doing our grouping method. And then, since both of these are the same, they're both x minus 3, I pull out the x minus 3 factor, which leaves me with a 2x here and a minus 1 there. And now I have factored my quadratic equation into x minus 3 times 2x minus 1. All right, so that's our AC method of factoring. Now, if I did that a little too fast or didn't quite make sense, like I said, go back and find the video that I did. It's called Factoring with the AC Method or something like that. And I do examples like this where I explain a lot more slowly and in more detail exactly what we're doing each step of the way. All right, at this point, I'm assuming that you've already done this type of stuff and you've already know how to do it, so I'm just kind of fairly quickly going through it. All right, once we factor this, I separate the factors. Set each one equal to 0. X minus 3 equals 0, which when I add the 3 to the other side, I'm going to get x equals 3. And then 2x minus 1 equals 0. When I add the 1 and then divide by 2, I'm going to get x equals positive 1/2. Right, so add the 1 over, I have a positive 1, and then divide by 2, I get 1/2, just doing those two steps in one just to get us to the solution there. All right, so I get x equals 3, I get x equals 1/2. Now, those are the solutions to this quadratic equation here. 2x squared minus 7x plus 3 equals 0. But remember, that was not the equation we started with. We had 2 cosine squared of theta minus 7 cosine of theta plus 3 equals 0. And we're trying to solve for theta here. Right, so I do that substitution of variables. I replace the cosine theta with the x just to make it easier to do all this factoring work and like solve that quadratic equation. So I get x equals 3 and x equals 1/2. But then, and I'm going to have to erase some of this work that we did up here, what I have to do after I solve that quadratic equation is kind of substitute back into my my original equation, right? So my x was equal to cosine theta. So if I plug in x equals 3 here, it's going to be 3 equals cosine theta. And if I plug in x equals 1/2, it's going to be 1/2 equals cosine of theta. Right, so I make the substitution of variables. I put it in place of all the cosine thetas. I put x. I solve that equation. I got these two solutions. But then I have to go back and put x equals 3 back into this this thing that I used to substitute. So 3 is equal to cosine theta. And I have to put x equals 1/2 there. 1/2 equals cosine theta. And now I have to solve these equations for theta. Right, because my original equation, the variable was theta. So I need to solve this equation for theta, not for x. Right, so we do that substitution just to make it more convenient to factor or to use the quadratic formula and actually solve that quadratic equation. But that's not the end of the problem once we do that, right? We still have to go back and substitute it back in to solve for the original variable, which was theta. All right, so now let me erase all this stuff, all that work we did to solve the quadratic equation. We've got that. But now we have to go back and solve our trig equations. So cosine of theta equals 3, cosine of theta equals 1/2. Right, so to solve a trig equation, I have my cosine thetas isolated on each side of the equation. So what I need to do is do the cosine inverse on both sides. Right, the cosine inverse cancels out the cosine function, and that's how I isolate my theta. All right, that's how I solve for that variable. Right, so theta is going to equal cosine inverse of 3. Now 3, that's not one of the numbers that I can get from my trig hand from the unit circle. And so, if it's not one of the numbers from the unit circle, I can go ahead and use my calculator. Just make sure your calculator is in radian mode. Remember, when we're solving trig equations, generally we give our answers in radians, unless we're told specifically to give the answers in degrees. So I do cosine inverse of 3. Right, so I type in cosine inverse of 3 and I get error domain. Right, there is no cosine inverse of 3. All right, so this one here, this side of the equation has no solution. Right, now you might think, well, I got an error, I must have typed something wrong, or I did something wrong, or this is not the correct answer here. It's okay, right? remember, the cosine function, if you think of the graph of the cosine functions, it bounces up and down between y equals -1 and y equals +1. It never hits y equals 3. Right? So there is no angle, there is no number that I could plug into theta that when I do the cosine of that, it's going to equal 3. Right? Because the outputs, the range of the cosine function is just between -1 and +1. You never get a value bigger than +1, you never get a value lower than -1. Right? So cosine theta equals 3 is not going to have a solution. Right? So it's okay that that happens. Anytime you have sine or cosine of theta equal to a number over here, if that number is not between -1 and +1, it's not going to have a solution. All right, so that side doesn't have a solution. This side will, because 1/2, that is between -1 and +1. All right, so cosine theta equals 1/2. We are going to get some solutions here. All right, so cosine theta equals 1/2. Go to my trig hand, put down my index finger. Remember, the number of fingers above gives me my x-coordinate, which is my cosine. Right, so and that corresponds to the angle of pi over 3. Right, so theta is going to equal pi over 3. Right, because if I do cosine of pi over 3, if I put down my finger for pi over 3, the terminal point is going to be 1/2 comma √3/2, and the cosine of that angle is the x-coordinate, which is the 1/2. Right, so, and let me actually erase this side over here. Since we got no solution over here, I'm just going to get rid of it so I have enough room to write some other stuff. All right, so if I do my unit circle, here's my angle of pi over 3. Right, and the terminal point for pi over 3 is 1/2 comma √3/2, which I get from my trig hand. If you don't understand what I'm doing with my finger here, you might want to go back and watch the video that I did on the unit circle and trig hand, where I explain how you can evaluate these trig functions just by putting down a finger or two here. It's pretty simple to do when you understand what I'm actually doing. So pi over 3 is going to be one of my solutions. Now the question is, the trig hand only gives you the solutions that are in the first quadrant. So is there another solution on one period of this graph on the unit circle between 0 and 2 pi where my cosine or my x-coordinate is going to be +1/2? And the answer is yes, there is, and it's down here in the fourth quadrant. Right, that corresponding point in the fourth quadrant is going to have an x-coordinate of +1/2 and a y-coordinate of -√3/2. Right, just using the symmetry of the unit circle, when I reflect that point over from the first quadrant to the fourth quadrant, x stays positive, but y turns negative. Right, because I'm going below the x-axis into negative y values. Right, and again using the symmetry, if this angle is pi over 3 above the x-axis, this one over here is pi over 3 below the x-axis. Right, so it's a full trip around would be 2 pi, but I'm stopping pi over 3 less than that. So I have to do 2 pi minus pi over 3, which would be 6 pi over 3 minus pi over 3, which is 5 pi over 3. All right, now, if you have the unit circle memorized, or if you watch the video that I did on how to figure out what these points are on different quadrants of the unit circle, you can look at this and say, oh, if this is the pi over 3, that one in the fourth quadrant is 5 pi over 3. And if you know that, you don't have to do this work to figure it out. Right, but if you're still not sure about what the pi numbers are, what the radian measures are for the different points around the unit circle, this is how you do it. Right, if this is 0 plus pi over 3, the one down here is going to be 2 pi minus pi over 3, and then just find a common denominator, subtract them, we get 5 pi over 3. So my other solution is theta equals 5 pi over 3. All right, those are all the solutions on one period of this graph. Right, between 0 and 2 pi. Those are the only 2 points where I'm going to have an x-coordinate or a cosine equal to 1/2. Right? Nowhere else on the unit circle is x going to equal 1/2. All right, so I got that. Now, to give all the solutions to this equation, remember, for sine and cosine, I have to add 2 pi k. Right? Now, if you haven't seen the other videos that I did on solving trig equations, especially the first one that I did where I explained in a lot of detail why we have to add this 2 pi k to give all the solutions, I would advise you to watch that. The real quick explanation is, remember, every time I go another lap around the unit circle, right, that's an extra angle of 2 pi, and when I do that, I end up at the same point, and that angle is going to have a cosine of 1/2. So if I do pi over 3 and then add 2 pi k, where k is any integer, any positive or negative whole number, I end up at the same point and I have the same cosine value. Right, so that's why we add 2 pi k for every solution I'm going to do another video now where I do another complicated type of an example, so check that one out.